This time, we are going to show whether the vectors on A, B, and C can be written as a linear combination of vectors U and V. To do that, since we have two vectors here, we have U and V, we need to show that a certain or two scalars, let's say K sub 1 and K sub 2, exist in a situation where let's already talk about A, where this will be true. K sub 1 times your vector U plus K sub 2 vector V. If we could show that K sub 1 and K sub 2 exist, then letter A and the rest of the vectors here for the same cases can be represented as linear combination of vectors U and V. So to do that, let's start with letter A. So already have here 2, 2, 2 is equal to K sub 1, and your vector U is 0, negative 2, and 2, plus K sub 2, you have 1, 3, and negative 1. Now, since K sub 1 is a scalar, so we can assume the scalar multiplication here. So you have 2, 2, 2. You will have K sub 1 times 0, so 0. Negative 2 K sub 1. And positive 2 K sub 1. Plus, here you have K sub 2. And then 3 K sub 2. And negative K sub 2 here. Now, we need to add the two vectors on the right hand side. Therefore, you will have this expression. 0 plus K sub 2 is just K sub 2. We'll have negative 2 K sub 1 plus 3 K sub 2. And then you will have here 2 K sub 1 it's minus K sub 2. Now, the purpose for this is for us to, since we have here 3 entries and 3 here as well, we can write here equations stating K sub 2 is 2, then negative 2 K sub 1 plus 3 K sub 2 is also 2, and positive 2 K sub 1 minus K sub 2 is also 2. These were all equations stating that since we have equality of vectors here, we can have that form. Noticeably, we have already identified that K sub 2 exists as a value which is equal to 2. Now let's try to check if this will satisfy the next two equations, and we'll get the same value for K sub 1. For this case, you will have negative 2 K sub 1 plus 3 times 2, which is your K sub 2, equal to 2. So you have negative 2 K sub 1, you will have plus 6 is equal to 2 here. So that negative 2 K sub 1 is equal to negative 4. So K sub 2 is positive 2. K sub 1 rather is positive 2. Let's check if this will also satisfy the last equation here. So 2 K sub 1 minus 2 is equal to 2. So 2 K sub 1 is equal to 4. So when you divide both sides by K sub 1, you will get 2 as well. So we have the same value here and here. So nevertheless, what it here is we're able to show that K sub 1 and K sub 2 exist, and as therefore A, the vector in A, which is 2, 2, 2, is a vector that is a linear combination of vectors U and vector B. So let's make it here. Let's just simply place here, yes, it's a linear combination. Okay, so it's the same thing we will do for B and C, but let's start with B, and I still have space here at the bottom. So same thing here, we need to show that this vector is equal to K sub 1 U plus K sub 2 V. By the way, here we are not sure if K sub 1 will still be 2 and K sub 2 will be 2 because it's a different vector now. But what we know is if we could show K sub 1 and K sub 2 to exist, then 0, 4, 5 as the vector letter B is a linear combination of vectors u and v. So we'll have here 0, 4, 5 is equal to k sub 1 and your u, which is 0, negative 2, and 2 plus k sub 2, your v is 1, 3, negative 1. So again, same thing as earlier. Let's distribute our scalar k sub 1 and k sub 2. This is still 0, negative 2k sub 1, and then 2k sub 1 plus k sub 2, 3k sub 2, and negative k sub 2. Basically, we will have the same left-hand side as item A, but we will have different values for the left-hand side rather. So still, let's just show it like this. 0, 4, 5 is 0 plus k sub 2 is k sub 2, negative 2k sub 1 plus 3k sub 2 here, and 2k sub 1 minus k sub 2. And having our equation, by the way, let's disregard this and we'll do it later. So our equations will be like this. K sub 2 is 0, negative 2k sub 1 plus 3k sub 2 is 4. We'll have 2k sub 1 minus k sub 2, which is 5. Okay, so we already have the value for k sub 2 here, and let's check if this satisfies the two equations. And if it did, it will rather, and k sub 1 will have the same result just like earlier, then we could also say that k sub 1 also exists. Substituting it in our next equation, negative 2k sub 1 plus 0 equals 4. Therefore, we'll get a value of k sub 1, which is negative 2, because that's a 0 and divide both sides by 2. Okay, and negative 2 rather. And here, we'll have 2k sub 1 minus 0 is equal to 5. Then you have 0 here. So k sub 1 is 5 halves. See that our result for k sub 1 for the next two equations are not equal. This would mean that k sub 1 do not exist for k sub 2, which is equal to 0. And ultimately, k sub 1 and k sub 2 for the vector b, which comprises of 0, 4, 5, is not a linear combination of u and v. So the answer here is no. Okay, let's have the last one. So 0, 0, 0. The same thing earlier. This 0, 0, 0 should be equal to k sub 1 u plus k sub 2 v. So you have 0, 0, 0. K sub 1, your u is 0, negative 2, 2. Plus k sub 2, your v is 1, 3, and negative 1. 0, 0, 0. Distributing your k sub 2 and k sub 1 scalar. 0, negative 2k sub 1, 2k sub 1, plus k sub 2, 3k sub 2, and negative k sub 2. Then vector addition, 0, 0, 0. You will have k sub 2 because that's 0 plus k sub 2, negative 2k sub 1 plus 3k sub 2, 2k sub 1 minus k sub 2. And then we just need to really show that we will have k sub 2 and k sub 1. They both exist with these equations. K sub 2 is 0, negative 2k sub 1 plus 3k sub 2 is also 0, 2k sub 1 minus k sub 2 is also 0. Let's try this value here, and hopefully our k sub 1 will be the same. So this is negative 2k sub 1 plus 0 is equal to 0. So k sub 1 will also be 0 over negative 2, 0. Here, 2k sub 1 minus 0 equals 0. Again, k sub 1 is 0. Since both k sub 1 values are the same, so we can say that k sub 1 is really 0. And together with k sub 2, which is already 0 earlier, both of them exist. This means that the vector, the 0 vector for R3, 0, 0, 0, is a linear combination of vectors u and v earlier. So this is how we show whether a certain vector is a linear combination of two or more other vectors, we simply need to show certain k sub 1 and k sub 2 scalars. And by the way, if we have additional vector there, so k sub 3 and so on and so forth, and if they exist, then basically we say that yes, that vector is a linear combination of the other vectors. Thank you very much for watching.